Hi everyone, in this video I'm going to explain to you what is Hess law. Alright, so as you can see the definition here, Hess law is when reactants are converted to products, the enthalpy change and the delta H is the same whether the reaction takes place in one step or in a series of steps. How to really understand this statement? So actually it is easy. Now let me illustrate to you. Say we have a reaction from A and then we want to produce B. Okay, and the heat involved is A. Oh, sorry. Yeah, so we name this heat as delta A. Okay, so the heat involved in producing B from A is said to be same if A produce C produce D, and then D produce B. So say this reaction is delta HB, this reaction is delta HC, and this reaction is delta HD. It is said that delta HA is equivalent to the sum of delta HB and delta HC and delta HD. So this is what is meant by Hess's law. Alright, which means you want to produce A to B. So the enthalpy to produce A to B is equivalent if A produce C, C produce D, and D produce B. Okay, so that is Hess's law. Easy, right? Delta H is the same whether the reaction takes place in one step, this one is referring to A to B, or in a series of steps, which is A to C, C to D, D to B. Okay, easy. Now, in this topic, you're going to learn two methods of the applications of Hess law, which is algebraic method and energy cycle method. So in this video, I'm going to explain algebraic method only. And for energy cycle method, I will explain it in the next video. So let's start, everyone. Now let's take a look in the first example. Now given the following reactions and the enthalpy, we have three of this. As you can see, we have 1, 2, and 3 thermochemical equation. Remember, when you have equation together with this enthalpy, this is known as thermochemical equation. Now, the question is, calculate the enthalpy of formation for this reaction. So the question is actually asking you to calculate this reaction. Okay, so this one. So how can we find the enthalpy of formation for C2H2 based on the data given to you, based on all these three data? Okay, so this is how we do it in algebraic method. You can see there are a few steps given to you. We have step 1, identify the target equation. So actually our target is this. Now let me write here 2 carbon. This is our target. And we are looking for the delta formation thing, right? So how can we do this? In algebraic method, we have to refer to the equation given to you. Now, since I'm looking for 2C we can find carbon here. So this is, okay, say this is equation 2. So I will rewrite it again. 2 carbon plus 2 oxygen gas, 2 CO2 gas. Why did I multiply with 2? Okay, as you can see, this one I multiply with 2 because I want, because our target is 2 carbon. So the equation number 2, which is this one, okay, you have to multiply it with 2. Same goes to the enthalpy. The enthalpy, we have to time it 2 as well. So therefore, we get negative 7, 8, 7 kilojoule. Okay. Now, since I want the 2 carbon, this is what I always do. I always block this. Okay. I will let you know why. So next, I'm looking for H2. So where is our H2? As you can see, our H2 is at the equation number 3. And we need 1 mole only, so we no need to multiply it. Write it here. So we get to at 5.9 kilojoules. So this one has no changes. And I block this. I call it I block this one. I call it blocking, okay? I block it. And next one, my target is the acetylene, C2H2. So here we have. However, as you can see, my target for this acetylene, C2H2 is at product side. But this one is at reactant side. So, what we can do, we have to reverse it. So, 2 CO2 gas, okay, say, plus H2O, and I get C2H2 gas and plus 5 oxygen gas. With the enthalpy, okay, now since I reverse it, then the symbol will change to positive. I did not multiply it, so the value will stay the same. Okay, this one. So I block this. Alright. Okay, so what should we do? Now, the one that we block is the one that we need to bring down here at the end. So the rest that we are not blocking, we have to kill it and let it die. Kill, kill, die, die. So I know you understand this concept. For example, like this one, our CO2, we have another CO2 here. This one at reactant, this one at product, so we can cancel it. Pop, pop. Same goes to the H2O, we can cancel it. Now, we have oxygen at the same side, so we have to sum both of it, which is 1/2, or equivalent to 5/2. So, just cancel this and cancel this. And the rest that we are not cancelling, bring it down to get this. How about the enthalpy? So for the enthalpy, it's easy. Sum all this enthalpy. Sum all the enthalpy here. And you are going to get, and you are going to get, okay, plus 2 to 6.7. Is it 7? 9, 6. I think the answer is 226. Okay, 0.5 kilojoule. So since the question is asking you enthalpy of formation, therefore rewrite again enthalpy of formation for C2H2 is positive 226.5 kilojoule per mole. Per mole is in cis. Okay, so is it a standard one? Okay, so this is not standard, therefore we no need to add note. Okay, because it is not at standard stat. All right, so this is the first example. Now let's take a look at the second example. Now for the second example, it is almost the same, except the question asks you to calculate the enthalpy of formation for ethane. So what is the difference between the previous example is that this one, we are not given the target equation. Instead, we have to do it on our own. So that is why I always emphasize the need to understand the definitions of the enthalpy. So when you see the enthalpy of formation for C2H6, means our target here is the formation of ethane. So C2H6 gas so we know this is for formation. So we know that the elements for ethane is carbon and hydrogen. So back here, carbon and hydrogen gas. Balance them. So this is 2 and this is 3. So this is what we are looking for. Okay, this is our target. Then we see for the first equation, we want the carbon and we need to multiply this with 2. This one with 2 as well. So we are going to get 2 carbon, 2 moles of oxygen, and 2 moles of carbon dioxide with the enthalpy negative 786 kilojoule. Okay, so plug this. Next one, I need H2. We have 3 moles of H2. So the second equations we have to times with 3. And this one also we have to times with 3. So we are going to get 3 moles of hydrogen gas. 3 out of 2. Oxygen gas. And 3 moles of steam. So the enthalpy is negative. Okay, this one. And the last one, we need the ethane. So as you can see, for number 3, we have to reverse it, and therefore we are going to get this. We don't need to multiply it as we need 1 mole only. So we have this one is the magnitude is the same but the factor is different, so this one will be positive kilojoule. Okay, all right, so time to kill. Pop, 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 and you get it. Okay, so sum everything and you are going to get negative 84 kilojoule. Again, since the question says enthalpy of formation, therefore rewrite again enthalpy of formation for ethane like this. You have to write like this. Is equivalent to negative 84 kilojoule per mole. When the question is asking you about enthalpy this and enthalpy that, it must end it with per mole. Okay, so this is algebraic method. Thank you.